Okay, I think the recording is ready. Anyway, let's wait till 5 and I can start introducing. Hey, Victor. Hey, Victor, are you good?
Yeah.
Mm.
Did I miss anything?
No, it didn't. We decided to wait till 5, till 5:05.
Oh, okay.
Yeah. Do you read the book?
No.
Okay, it's fine. It's fine. Yeah. Let me check the next chapter as well. I think yeah. Like, if we're gonna keep this reading, what will the next chapter be? Chapter is intelligent agent. Hmm. Environment, actuator, action, functionality, nature, test type. Okay, it's 5:05 now. Let's start. So, since we have a few people join here, if you had read the book or not, you can just type in the chat to let me know. Or if you had read it, let us know how much time you spent because this is indeed a very big chapter. I think it's definitely like exceed our expectations. Like the content is quite a lot, and if you're not that interested about history, you're probably not gonna have a good time. Yeah. So yeah, but anyway, I still finished a chapter, and I think it's around the same as what I expected, because this is a very classical level textbook. So usually you would spend at least a bit of a chapters trying to tell you about what exactly is the background and what are the pitfalls that people had faced before. Yeah, I also see like Hosam is here. Hosam, are you around?
Yeah, what's up?
Mm-hmm. I mean, yeah, we just got started, and I'm just talking about some random stuff. Um,
hmm
I've actually made notes for all of the four small chapters. Do you do you think we need to like split the work to chat about it, or you want me to do it?
I mean, like, sure, like, I don't know, like, how are you gonna walk through this? Like, are you gonna read the textbook and then like go through the summary, or gonna just read the summary?
Okay,
I don't know, like,
I'm mostly
what
just
do you
gonna
think
read a
about it?
summary because I'm the textbook itself is pretty long, so I would just try to quickly skim through what the ideas of AI or something.
hmm
Okay,
Okay, sure, go ahead.
okay. Let me just do like two chunks, and then see how it works. Yeah. So
Okay.
the first chapter of this book is, as you may see, it talks about lots of like background knowledge you might want to know about AI. Those aren't the exact um, resources you might be used to, like really build a machine learning model, at least for the very short term. You might be able to only apply or use these philosophies in the long run. Like, hey, when you really hit the obstacle, you might need to go back and look at what have people done in the past that have failed. Um, you might also happen, let's say, when you want to deploy a real world application, and it actually will affect a lot of people's lives, and you suddenly need to be regulated. So in knowledge that's being used in this book, it's kind of like that, and also there's a bit of like a branch knowledge, talking about what are the fields that's related to AI that affects AI or originate from AI, and those subjects are I think a bit more interesting if you if you happen to be like a generous type of person, you would like to not only learn how to be an AI engineer, but you also want to apply it to a various amount of fields. So yeah, and let's go to the first part, which is I believe 1.1, is it? Let me check. Yeah, so the first chapter it has a lot of sub chunks. Um,
Mm-hmm.
1.1 is what is AI, and I do believe this is a very, at least among all the chapters, this one is quite important actually, because as we learned in the lecture, the teacher did ask about like what is your definition of AI. People say Skynet. People say what is it called? People say a lot of weird things like humanoid robots, or people say Atlas or something. Um, but over time, there's actually had been some like standard. There's actually had been some consensus about what's a better way to define AI in terms of effectiveness. So if you look at the kind of this table here, um, people usually don't really have a very good idea about AI, but there's like two different columns or rows to think about it, and there's like different combination of results. You can think of AI as it should be a humanly machine. We don't care about whether it is effective or smart or not, but because humans are actually dumb. But as long as it, it cannot be differentiable from the real human, then okay, we say it's AI. But the other way to do it is that we don't necessarily just want the stupid robot like a lot of our humans does. We want a robot that always make the best decision or best choice. Um, I think that had been seen in lots of fields. We don't really want a surveillance AI to just be able to do what a regular guy could do. We actually wanted to have like supervision. You can detect very subtle features of a picture, even if we themselves cannot do it. So the this is the difference between humanly and rationally. And in terms of how do you achieve this result, there's also like two branches. One is that you think the way that AI perform this result, they should act as human as possible. Let's say if a doctor AI were to would do what? Let's think about a example. If a doctor AI were to do an operation against you, do a surgery against you, would you want it to do the human way, which is that you will always hold a knife using its hand and try to cut through vines exactly the way that humans does it, or you want it to kind of what, or you want it to behave however that's effective. Like I think this is think humanly part. Like, do you really want it to achieve the way exactly as we do it, or you can use whatever way that's effective? Yeah. So I think in the very early days of AI, even in the era of like Alan Turing, people have been thinking about links for quite a lot, and we can explain it one by one. The thing that's called humanity is trying to preserve at most fidelity of human as possible, and the famous Turing test is kind of like a benchmark to verify this. As long as you look at human, as long as I cannot tell if the AI is deceiving me, okay, let's say not AI. But the problem for this test is that there's like a few problems of it. The first problem is that humans aren't really that smart. This kind of from case to case. We have very smart humans. We have humans that are just generally kind of ass. So why would you want to build AI that is sometimes smart and sometimes dumb? It doesn't really make sense at all. Would it really be that effective overall? And the second problem is that um, what exactly is it for you to act like human is also like a kind of like an inconsistent criteria. Like maybe an AI can sometimes be look at humans. Maybe in some fields the AI couldn't be tell from a very good human being like ChatGPT, but there might be some fields that okay it is apparently it's fake. So the goal was really not that clear. So they also give an example here, like um, the quest of like building flying machine had only took off after engineers and inventors start to fake birds. We don't really build our like what we don't really build our airplanes to achieve the goal that it looks exactly like a pigeon. We just have to build it in a way where okay it at least achieve the flying objective. So this go to act humanly actually being kind of obsolete. We don't really do that anymore. This is just like an early idea of when the AI started to boom. Second one is kind of like the state of art here, like rational agent. It just means that we don't really care about what the AI looks like. The AI could do a surgery using some very scary or ugly procedures or tools. As long as it achieves our result, which is humans' result, we think this is a good AI. We think it's a thing that we want to do. So they kind of call it like a rational agent. This means that as long as it achieves what the goal is, we think that's a good thing. Yeah, and the other branches to think humanly or to think rationally is also like another definition in the past. Think humanly actually appears like first, according to the history. Um, the early idea was that if the idea was that since no one knows how to build an AI, how about we try to decode the human mind first? We first try to understand how the human brain and how the consciousness work, and then we build a machine to emulate that. Um, and this path turns out to be like even harder. Like human brain and human mind is so sophisticated that till now we literally have like very little progress on neuroscience. Um, and so people, because of that like disappointment, people had been trying to use like psychology to model human's mind and try to build machines based on psychology. As far as you can tell, this is like a very awful way of doing things. Like there's some like very famous results like general problem solver from Neil and Simon, and a few like early attempts in cognitive science. The result for this was that if you were to build a machine against your like psychology guesses, most likely the researchers themselves would be hallucinating quite a lot. Like the researcher at one moment might think that okay, human mind works exactly like this model, and then they try to build this model as a machine, and then they themselves become convinced that hey, this is correct. so, so so yeah, this is also a failure attempt. Apparently, modeling using psychology didn't really work. Although, like the book did say that computer vision did benefit from it by a bit. They didn't really go deep into this, so I'll just not tell about it. Thinking rationally, this pretty much just means that we use whatever formal tools or tools that had a good model consistency to model out the process of like reasoning through the behaviors. And yeah, and this is kind of like thinking rationally and rational agent is kind of the so-called standard model here, which have been proven to be the most effective in the past. Yeah. So no psychology, no looking at humans. Okay, and the last idea of the 1.1 has to do with value alignment. I think maybe a lot of you, when you read this chapter, you'll feel like, hey, what exactly is this value alignment problem? You feel so lame. I don't even know how to build a machine learning system yet. How do I care about it? Yeah, but this is actually just like it's kind of like a future problem that you probably wouldn't touch it now. But it actually happens to be quite dominant these days, which is that as we build more and more capable agents and we deploy them to very complicated environments, we might not always have to or can set up like very concrete goals for them. Let's say we tell you to just like we'll deploy to Mars and tell you to make his own decisions to make Mars habitual. Then we really know what habitual really means, or it could be expressed in a lot of different ways. So But still, the goal itself is naturally kind of blur. It kind of requires some afterthought, and then to do some trial and errors. So how do we align this objective, like somewhat blurry objective, to the AI? That's the value alignment problem. And you might think that this is like not a so important thing at all, but it actually turns out there's lots of positions about it. Like if you look at randomly on LinkedIn, OpenAI do have had a team that's called the super alignment team. If you had heard this word before and didn't know what it is, it's actually just doing this value alignment problem. Yeah, so in most of the artificial intelligence labs, this have been actually quite popular. And if you even look at the positions on OpenAI, they had exactly the position to do alignment as a research engineer, research scientist. So if you actually work in this industry, it's probably something that you need to touch. Okay. Any questions in this part?
Mm,
Mm-hmm.
I think it's pretty clear.
Mm-hmm. Sure.
But like there is something that I've read about like the part of being uh, the the idea of or the approach of building a humanly thinking AI
Mm-hmm. Mm-hmm. Mm-hmm.
is like it was based like somehow on like having a problem and like distributing the problem into like many sub goals and like try to achieve those many sub goals as like a human does in any problem solving
Yeah,
technique.
yeah, yeah, yeah.
Like for instance, like playing chess.
Mm-hmm.
When you play chess, like you have like the main goal is like to checkmate your opponent, but like you also have like many sub goals. Is like
Yes.
for instance to take the middle square or like to take over pieces and stuff like that.
Mm-hmm.
So that was the way that they were approaching AI, or the way they were thinking AI should do in order to solve other problems. But
Mm-hmm.
like later then they discovered like no, there is like better approaches
Yeah, yeah, yeah.
than this way of solving like problem
Yeah,
as human
yeah, yeah. I also
as
kind
what
of
the
heard
human
that.
do.
I just think that's from what I can recall, that's somewhat related to the approach that Newell and Simon did. They are trying to model the human thinking process, but it turns out that the human thinking
Exactly, yes.
process is more or less like a byproduct of the action. So if you were to only model the thinking process, the result isn't really necessarily good because you are still missing some ingredients.
Hmm.
Yeah, yeah.
Exactly.
Okay.
And,
Then,
and like there
mm-hmm,
were like a specific model that they have built for like detecting something in the brain or something like that.
mm-hmm,
It was like a medical model, and like this model was built on like rational steps or like logical steps that were
mm-hmm,
uh, extracted from like human doctors. Like
mm-hmm.
they were like they've interviewed like hundreds of doctors, and like they have extracted like logical steps and like just fed
Oh,
it to the AI
yeah.
in a logical way, so it can like predict whether a patient would have a certain tumor or certain disease
Mm-hmm.
by like rationally asking some questions.
Yeah, yeah, yeah. All right. Let me go to 1.2 then.
Yeah.
Sure. And then
Okay.
1.2 is mostly about like the fields that's related. If you hadn't worked in any of those fields before, it's also probably a chapter that you wouldn't be so much interested. But if you are at least had programmed before, doing some robotics before, or you have some mathematical background, I think this chapter is actually somewhat good to at least make that you understand that what's the direct applications that you might be need able to mix in. So I'm just pretty much like summarizing this into three cards. The first one is that the fields that contribute to AI. And I just going to go through this very quickly. Regarding how exactly it works, you can just read the article. You can the first thing that affects AI, that contributes to AI, is definitely philosophy. Like philosophy contribute AI in a way where it all of our pretty much all of our logic system right now is originated from philosophy. So that's one thing. Also, I think philosophy is one of the first fields that try to think about, hey, um, does consciousness really have a place in like human intelligence or something like dualism or materialism? Materialism pretty much means that there's some separatable conscious from the machine parts of our body or something. Yeah. So this is the early origins. People are pretty much just thinking at this stage. They didn't really build anything useful. And after a while, I think in like 15th century or something, lots of theories try to come out on how do you exactly do science, and where does wisdom exactly come from. Like this word, I don't really how to read it. It just kind of says that I think it corresponds to one of the slides the teacher gave, which clearly labels like knowledge, information, insight, and wisdom or something. So the argument of this theory just says that wisdom is something that you cannot do just by data or something. You must mix in like experiences. You must become insight. It must become something that you can act in order to be like a true wisdom, not just a piece of data. And there's like also like a few other a series regarding in terms of like scientific inquiry. Like they say that if you want to establish a wisdom, it must be observable and falsifiable in some case. You cannot really build an AI and just say that, hey, I think this AI corresponds to myself, and it also thinks so. You cannot do it this way. You must be falsifiable. Yeah, and then there's also like a few like series regarding can knowledge be separated by action or something. I think if you were to build like real agents, you probably would think about this problem, but at least in the early stages, this was only like in the soft stage or something. Yeah, and also there's some feels like people had attempt to define human ethics themselves, not to just guide AIs, but to guide ourselves. Yeah, so till this day, let me just take a look at this. Yeah, there's like different. I don't know how to name this word, but there's like different branches of ethics that we can do. One is to make sure that your decision will yield max utility. Even if you were to commit a crime, at least if that crime were to benefit the whole society in a good way, then we will not punish you. And the other theory of like ethics is more or less on rule based. Wait, someone say something? Okay, no. Oh, yeah. Another from Kant, which kind of proposes like the rule based thing, like you cannot always lie, you cannot always kill people or something. In the book itself, I think it tells us that what usually the way that we do value alignment nowadays is to try to mix in like both strategies. As a core, overall, I think we do want to achieve like better utility, because that's pretty much what the human society works right now. But on a smaller scale, we will try to achieve that maximum utility via just making up real rules. Yeah, so I think this part definitely hasn't been defined very well yet, because even human ethics, let's say laws, it still require lots of like explanations and things. It's still a very inconsistent field. So although we can be inspired by some of these things, I wouldn't say it's like exactly that valuable to us yet. Yeah. And then there's some decision making theories like, hey, if you were to have 3 agents, how can you maximize the utility or something? Yeah, so okay, those are things that inspire AI. Not so interesting, probably not so useful as well, unless you try to become a scientist against it. Okay, next thing, mathematics. So mathematics, you will see lots of like very familiar stuff from our mathematical 1 in other courses like propositional logic, truth tables, and first order logic. So all those things do have like very noble, very good origins. In case that you don't really know the difference between those, I suggest you to check it out and try to read against it. It's actually quite interesting. So basically, the history tells us that we first started from having propositional logic and truth tables. Hey, awesome! I think you have a typing sound.
Oh, sorry.
Yeah. At first, people trying to just like formalize the mathematical system because mathematical systems before a certain time is actually as consistent as we do nowadays. You can just imagine that the former mathematician like Newton, they don't really write very formal proofs. They just write, hey, given something, learn something, then I prove it. So even mathematicians at that time sometimes makes like very sloppy proofs that you cannot really even comprehend that much. So that kind of leads to the 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 attempt to formalize the entire mathematical system. We can only use certain rules of deduction to build up conclusions. But that kind of lead to like problem from Godot. I don't exactly remember like which teacher tells it, but you can just like look up online on how famous this person is. It basically just says that no matter how well you define a system, there's always some proposition that you cannot really prove it. So that's kind of a disappointment. But based on Gödel's like incompleteness theorems, it actually leads to like the field of computability. Okay, sure. It leads to like the theorem of computability, which best to in shorter words is that scientists start to think about, hey, since there are some theories that couldn't be proven, then um, can we just like make a set of problems or categorize problem to a different set that says, oh, okay, all those problems are definitely gonna be consistent. They are definitely computable, and there are problems that we definitely cannot solve. Yeah, so that's kind of like Turing's attempt. There's like two models of it. One is called the Turing machine. Another one is called the lambda calculus. It actually happens to be having equivalence. You can just say that most problems that computer is able to solve is modeled model what? It's modeled around like Turing machine or something. Yeah, and so far, at least far what we know, we haven't really found like a completion model that's better than Turing machine in which we can implement it. I think although we haven't formally proved it, I think scientists generally kind of accept the fact that Turing machine is the best model we will have, and it pretty much can solve any problem that the physics allow us or something. Like it probably cannot build like time machines, but we pretty much just assume that time machines doesn't exist at this point. Yeah, and uh, and the second part is like statistics and stochastics. I think we're probably gonna learn about those a bit more in our first semester. Um, some of it is called Bayesian statistics. There's also ANOVA method or something. I just skip this for now because it's a story to tell in another day. And that thing is like computability theory, which is related to this. Okay, I have already talked about this. I'll just like to add a bit on the last part, um, which we are gonna touch very soon. There's as we try to model how problems can be solved by computers. There's also another branch that try to model like the relative difficulty of problems. That is related to NP completeness. Like we start to categorize problems that's extremely hard to solve. It has like very high complexity and difficulty. We might not even solve a problem if we were to brute force it using 1,000 years or something. Yeah. So these are the type of theories that comes out, and then that part is just some fields that are more far fetched, like neuroscience, psychology, control theory, and NLP. Yeah. Right. So and one of the biggest thing that they talk about in the chapter is that the biggest the biggest difference between control theory and AI is that control theory are a lot of times thinking about continuous mathematics. So they happen to use like integrals, using differentiables, using lots of like signal processing techniques quite a lot, while AI in the past have been dominating by discrete mathematics quite a lot. So that's the reason that control theory isn't exactly belongs to AI, at least for a current era. But they've been trying to integrate from time to time. Right. Second part of it. Any ideas?
Now I have like some things to say about like control theory
Okay, go
and
ahead. Go
how
ahead.
it is related to AI.
Go ahead. Go ahead.
As like examples of control theory is like when you're trying to control basically there are like tasks that human can never do, and like machine will always defeat human in terms of it. Like
Oh.
for instance, controlling a robot with like 500 actuators, for instance, or like
Uh huh. Uh huh. Uh huh.
even like an arm of a robot with like 5 actuators. A human would never like be able to control the 5 actuators separately in order to uh, like express some kind of motion.
Mm-hmm.
So this task is specifically designed for machines and for robots. And like the control systems that have been, or the control theories that have been developed in in the earliest times before the methods of machine learning and AI would take over, were like some sort of linear control systems where you model a system in a linear order.
Mm-hmm.
Like if you have heard of like differential equations, there are some sort of linear differential equations where you model the linear part of the system, and that have restricted so much the capability of a control system to be able to preserve a set point for the system.
Mm-hmm. Mm-hmm.
Like for instance, if you're trying to control the level of a tank, okay, and you have like a valve that is pouring water into that tank, and like there is, for instance, a pump that is removing that water from the tank. For instance, like you want to control the tank from overflowing or something like that. uh, the differential equation, or like the equations that defines this valve, are like nonlinear differential equation. But like in order to design a control system, in order to control that valve, you'd have to linearize some sort of approximate those equations, which has limited the effectiveness of the control systems. And now like when AI or machine learning have been developed, it has like eliminated that thought process of linearization, and like you can just directly model the system in like a very accurate nonlinear way.
Mm-hmm.
And there is some interesting field in AI also called the physics informed neural networks, if
Mm-hmm.
anybody have heard about them.
Yeah.
A physics
Yeah. I
informed
heard
neural
it.
network is, have you heard about it?
I heard Yusuf talking about it, but I don't really understand what is it.
Mhm. So basically, have anyone heard of like simulation programs, like computational fluid dynamic programs, or electromagnetic Maxwell simulation programs? Basically, like anything that describes a physical system is some sort of a partial differential equation. Partial differential equations are known for like the impossibleness to be solved. Like you cannot solve a partial differential equation by hand.
Oh.
That's the case. So the only way to solve a partial differential equation, that's because of it has a lot of dependencies, very, very high dimensional uh, properties. So in order to solve a partial differential equation, you'd have to use a computer and discretize the partial differential equation into small chunks of linear equations. And that chunk is that you can solve analytically by hand.
Mm-hmm.
So, for instance, like you want to model the flow of fluid, or the flow of air on a car, for instance. You want to test the aerodynamics. You want to test if that car would have a high drag, or a dangerous lift that could like tip the car over, for instance, at a certain speed. So what you're gonna do is like you'd have to take the air all around the car and like discretize it into very, very small little chunks of air, like very, very small little cubes. And in each cube you'd have to solve a specific equation for that cube.
Mm-hmm.
And the order of this process gets magnificently complex when the domain of modeling or the domain of simulation gets highly and highly uh, I mean, like greater and greater, bigger. You know what I mean? Like, for instance, a normal problem that you would solve for like 100 million elements. 100 million elements is like you discretize your domain into 100 million elements, and each element you solve a specific equation for that element. And like
Mm-hmm.
so you'd have at least 100 million unknowns that you are solving for, let alone if you are competing for like more than one property. Like for instance, if you're computing for just temperature of the fluid at each point, you might be interested in computing the density at each point. You might be interested in computing the velocity at each point. And like the velocity, for instance, has three magnitudes: the x direction, the y direction, and the z direction. So you can deduce that it's a very, very computationally expensive approach. And a simulation like this could take like for like even supercomputers like days and weeks in order to be able to solve that. Just in order to be able to model the simulation of a car, and like just to deduce if that car would of that if that design if that specific design of a car would like give a high drag or a low drag or whatever, or it would perform better than other design. So like a problem like this would used to take like thousand and like sometimes tens of thousands of hours to be able to compute that, even with like the most advanced computers that we have today. So the physics informed machine learning have been developed to address that problem in a very, very unusual way. So like you would imagine a neural network that is have been or that have been trained to predict the output of the simulation without actually solving the simulation. And that is the point, like that is the magnificent approach of that. Like you don't go through solving all the equations, but like you just from the boundary conditions or from the shape you can predict how the output can be. And like how something like that is formulated is like by having a neural network being trained on physical system or like the simulation itself.
Oh, okay.
And what is interesting in this is like you don't need a ton of big data in order to do this. Like for training any other like neural network in any other field, what you basically need to begin with is data, tons of data. And like those tons of data is like sometimes hard to achieve, hard to acquire, and like sometimes they are like locked in books, like things like sometimes
Yeah, yeah.
old books, like things that you
But
can
with
find
for
hard time
physical
to
systems, you
extract.
can just stimulate them and feed in them with like generated data. Yeah,
Yes,
yeah, yeah.
exactly. And like in physical systems, like you have the equations that model the physical system. You just have to make the neural network learn how to predict outputs based on those equations.
Okay.
And that's the point. Like it can like run tons of simulation and extracting tons and tons
Right,
of
right,
data
right.
without even like searching the internet or something like
Okay,
that.
okay, okay. So I guess the way to understand it, at least for me, is that um, aside from trying to solve the problem fully, we're trying to come up with an approximation of the problem, and as long as the approximation is effective enough, we can use this in the system to control.
Hmm.
Okay.
And like things is like uh, when we go to discretizing a problem, you are already approximating the problem, as like you are uh, subdividing the domain that you are solving for into like very, very small little subdomains, and in each subdomain you're approximating the equation into linear equations. So that approximation does like make you lose some sort of accuracy, and like it's like approximation either wise, but uh, it's about like more computationally efficient than like the approach that would give you the best computationally efficiency than the other. That's the point.
Sure. All right.
Mm.
Okay.
And the thing is, like
Mm-hmm.
scientists, like one more point. Scientists back then were like studying AI or like thinking of AI as something that would do human-based tasks, and like
Oh.
it would be only restricted on human-based tasks. And like they have never thought that AI could itself be used to do like machine tasks better than machines itself, or like better than the algorithms that have been used in solving those tasks for the machines.
Okay. Okay. Then I'll just like go through the rest of content pretty quick because there's not much left. Okay. Okay. Next chapter is all about like history, which is 1.3. Let me just jump to 1.3. This is also like a long ass chapter. But if you were to just summarize it, can read it, it's still doable. Okay. So basically, it kind of tells about like, I'm not sure all of you had heard of like AI winters. It just pretty much means that in the past of AI, there have been certain moments that people get extremely optimistic. Let's say, we're definitely gonna do it. Humans are stupid. We can make better machines as compared to humans. And suddenly they will see themselves become like overly optimistic and they will just fail dramatically. Companies go bankrupt and scientists stop to receive funds. And there's also like some psychology that comes up of different era, which I will explain one by one. The first era is like from World War II to like 1950s. Basically, on our time, it's about the same time as I think cognitive science were to first exist. Um, they are kind of still arguing about like some of basic things. What first of all is that whether human intelligence could be categorized as a part of computational process. Like, is human just a biological computer or something? And and this assumption turns out to be kind of true. Like, pretty much we at this point we are convinced that most pretty much all of human knowledge can be described using a computational way, but also it doesn't exactly work as a computer. It's not exactly symbolic. We don't really follow like a very formal system of logic. Um, the other assumption they had at the time was that what if we can understand the human brain, like in how a neuron works first, and then we can build up entire brain from neurons, and therefore build up artificial intelligence. These assumptions turn out to be completely wrong. It's a bit like economy. Even if you were to know an individual behavior, it doesn't really tell you about the bigger picture. So this happened to be pretty wrong. You could have built like a neural network or that stimulates neurons, but as a whole, we still don't really know like how can you train the entire neural network to be very smart. So yeah, this is still pretty wrong. Oh, we only have 15 minutes left. Fiber. The other thing that comes up at that stage was that how can we build like a system that can learn? This actually turns out to be pretty useful. A lot of the histories we use in deep learning, like backpropagation and a few stuff, and the basic assumption of using neural networks to learn, it does actually come from this stage. So you can say that this is quite it did forecast the future and gives us very good tools. And that statement was actually made by Turing. Turing basically just say that he thinks that just building machines in an algorithmic way isn't really gonna be bring us anywhere. He thinks that we should have the system learn by themselves, other than we hardcode rules. So this is also not be correct. All systems that hardcore rules that eventually failed, and yeah, so there had been like a few reasons on why this failed, but you also had that with some legacy. And the next era was that they tried to escalate with those assumptions and try to build real machines. So you can see on the thing here, most attempts they built here turned out to be pretty wrong. That's exactly the problem that I described in the earlier chapter, which people are just trying to model machines using psychology, and it turns out to be extremely unuseful. This is like two problems. Like the first two problems is that they want to make the machine think humanly, which turned out to be super ineffective. The second part is that they are only modeling AI using like a toy world. Let's say it's only using it to solve like checkers, or it's only used it to solve like the toy picking problem. And then as long as they solve the checkers problem, they say that hey, this AI is now capable of solving Go or harder real world problems. It turns out to be pretty wrong, and people learn their mistake from it. Yeah, so there's also reasons that why this failed. Um, just go through a few of them is that like, if you were to deploy like a toy world to a real world, you will actually not work because of the computational cost is too high. And they also care a bit too much on using symbolic logic to represent problems. And it was also too psychologically grounded. The system cannot really learn because they also hadn't exactly figured out how to apply learning to the real system yet. The learning hadn't been established yet. And so system has no common sense. You just don't know what the humans, you just don't have the general knowledge of human. So in after its era, I think is where I think in the 1960s or something, a lot of like people have been criticizing about the way that people do things because they were receiving lots of funding and no results when come out. So at a certain point, the UK government decided to stop all funding to AI. So the entire thing just collapsed. Yeah. And let's go back to the next part. So this is basically like just early attempts, something people had done wrong before. But a lot of our classic theorems were actually established from the time, just that they aren't able to fully utilize it yet. And the next part of it is that is expert systems, which we would say that this is the first like era which AI are still pretty dumb, but it can do good things already, and it becomes commercially effective. So what I'm trying to do there is that they try to mix in a lot more because they kind of know that there's like all those problems in building like a general agent. So they just kind of went another way. That's saying that how about we just try to collect wisdom from the humans and just make the wisdom a machine. Of course, you could nowadays would say that, hey, is that really artificial intelligence? Is it not just like you're building like a machine to automate your task as an expert or something? But this way turns out to be quite good, especially when the series aren't really that developed yet, and you don't really have the data or the hardware yet. So at that time, they are able to use this method to at least you can kind of say that shrink the problem set to a smaller scale and just use a few rules to deduct the results from. So in 1980s, so those expert systems, like we can just say that rule-based expert systems already had lots of uses in real world. You can just you can use it for like supply chain forecasting. You can ask it to like plan certain routes for you or aid you with the decision process. So it actually turns out to be quite good. But expert system also does has a quite a big problem. They also have like a very clear bottleneck, which means that because their intelligence comes from shrinking the problems, which means that by theory they cannot really ever scale to bigger sets of problems. You naturally be kind of limited, and also at a time like LM hadn't existed yet, so the system actually had very little understanding about natural language. They were trying to build like NLP system from linguistic knowledge at a time, but it turns out to be pretty shit. They just pretty much the result just pretty much tells us that linguistic isn't really the source of our language. So using just linguistic cannot really tell you what a person means. Yeah. So that's kind of it. Of course, at that time there were also some system like MYCIN that's trying to mix in of some probabilistic probabilistic decision process. Like if a doctor were to given a blood sample, you wouldn't necessarily just say that, hey, this blood sample means that you have AIDS. You will actually give you a probability and try to reason through a probability. So you can also say that this is a very attempt of like what is it called, probabilistic reasoning. Yeah. So at a time, I think this is like not a bad chapter. It just kind of means that, hey, we know that we have some very big deficiencies in terms of describing problem, in terms of solving problem on a bigger scale. So we try to reduce the problem using our own knowledge. But the deficiency was that we must always know that expert systems or rule-based systems, they actually have certain level of deficiency, including like the control theorem problems that Hossam talks about. They are just problems that we cannot solve it completely, and expert system exactly failed at it. Yeah, and so after we conclude this chapter, it's all about like state of the art, which I just go through in very quick because of eight of like very established neural network series, and also RL, and also like people trying to um, build like shared benchmarks. Like, hey, for example, we have ImageNet, which is the computer vision shared benchmark. People started to mix in lots of different series inside, that actually builds up the prominence of modern AI. And also deep learning happens to need lots of data set and powerful hardware. And all those have been kind of is a bit like a coincidence, right? Just that everything that deep learning needs happens to be first at this moment. Like in the past few years of like social media, there are a lot of companies that like collected like terabytes, petabytes of data that's available for deep learning to train on. And in the past, because like Moore's law, the hardware had been good enough to exceed like the capability of human brain. So that also made like modern AI kind of possible.
And like the point of deep learning is like very crucial to understand the difference between deep learning and machine learning.
Mm-hmm.
And like basically deep learning is a subset of machine learning. Machine learning is like the bigger picture. It's
Mm-hmm.
like basically training any AI model. And like
Yeah.
AI models, there is a tons of AI models that you can train. There are like decision trees, KNNs,
Yeah.
like different types. Like but like deep learning is like specified for training a neural network AI model.
Oh.
The model that have like networks and like there is that those deep layers and like there is that surface layers and stuff like that. So deep learning is like specified for training the neural network AI models. That's it.
Okay. Okay. But machine. But what does machine learning means then? Does machine learning means that we train a system that can be learned? Is that a
Yeah,
definition?
like machine learning is like building a model that like can solve a problem basically. So it can be anything. Like for instance, if you have like in like a logical conditions, if else conditions, like cascaded and like or sequentialized. Like if something happens, like do this. If that happens, do this.
Mm-hmm.
So this is like not specifically known as like AI or like, but it's machine learning,
Mm-hmm. Mm-hmm.
and in some sort it could be treated as AI or like a machine that is doing something, some sort of based on rational or based on decisions, and like observations and decisions. So that's some sort of an AI,
Okay. Okay.
but like it doesn't necessarily have to be a neural network.
Got it. Got it. Got it. Got it. Okay. Another thing is that our meeting is about to end. I think we took more time than we expected. I'm just gonna paste another meeting link, and we can just join that instead. All right.
Yeah, sure.
Yeah, I just paste it here. Let me just open up SS very quick. Open. Sure. Okay, I paste it. Please join that instead, so we won't be kicked. All right.
Hello.
Hello. Hello. Hello. Oh, I hope people are joining. Okay. Let me just paste the link in the chat as well.
I didn't expect that you would like do the summary of like even my part.
Oh, okay. I mean, I just did it because of just no reason. That's just the way I study.
That's good. That's good. Anyway, like I've did a summary like I would like to share with you if you're interested. Like
Sure, sure.
in a way,
We can go through that.
uh,
Yeah.
I did it like in some sort of a PowerPoint way.
Oh, you made a PowerPoint. Wow. Oh no.
Mm-hmm.
How much time do you spend on reading a chapter? A lot.
I didn't read the whole chapter. Like I just read the 3 and 4
Okay. Okay.
sections.
That's still good. That's still good. You know? Yeah.
But like it didn't take me much time. Like
Got it. Got it. Got it. Okay. People aren't
hour.
joining. Yeah. But we're in our 1 to 2 minutes. I'll get some water. Just get some water. Give me 2 minutes. Wrong keys. Harder. Okay. Okay. I guess we can just continue it.
Yeah, carry on.
What's my cam misaligned? Okay, sure. All right. Okay, let's just go back to the last few bits. So the state of art, just I don't think there's that much big information that's being baked in yet. Um, you pretty much just try to talk about like what our AI system trying to do. It didn't really talk about the state of art series or something. But it just tells us about, hey, has there been any effort to forecast what will happen in the future? And usually, like human experts are pretty bad at forecasting things. They couldn't even predict a war that's happening or any technology progress. If we were to like do some searching, there's actually like a website called Meta Clues that it has a few problems that trying to predict, hey, would a war happen in some country or when will AGI happen or something? And you can just tell that these predictions are sometimes pretty stupid. Yeah. And then yeah, so I don't think you really need to kind of I don't know. People just want to predict things a lot. Even like as for now, like OpenAI tried to tell you that AGI is gonna happen within 10 years or something. Um, but if you were to work in academic, probably the thing you have to do is that you probably don't have to be that optimistic or pessimistic. You just solve whatever problems you have in your hand. Yeah. So this just pretty much tells you that no matter how optimistic people are, just remember there are failed attempts in the past. So who knows that we are not gonna bump into another bottleneck in 10 years. And there's some footnotes about like what the author thinks about in the current development of AI. I think the author also isn't really expert about it. It just kind of says that it just kind of concludes that, hey, we're first thinking about whether building a machine of intelligence is very possible. Then they are thinking about encoding knowledge into logic, and then that didn't really scale. So we eventually have to do probabilistic models, and they are also kind of like thinking that what is it called? Yeah, they also kind of thinking about like whether the standard model, which is rational agent and act rationally, whether it is it totally the best model we had, or there should be something that replaces it, some strategic whether we can have a better strategy about it. And some footnotes, yeah, it just kind of concludes it. Do you care more about like making the best result, or do you care more about having acumen? Okay, that's pretty much the conclusion of the chapter. I've drawn a little map regarding how those ideas connect together. Um, but the chapter isn't really that big either. So, I mean, the chapter is big, but the ideas isn't really that complicated either. So you can just look at it and check if you understand everything. Yeah. I know, Hossam is trying to say something. Do you want to read the slides, or is there something you want to supply?
I mean, like adding to this, like I think that this chapter was basically built on history of AI and like how AI have been progressed through the years. So basically, like the info is like pretty much covered. Like you pretty much did a good job like covering most of the info in this chapter. And so as much as like this chapter doesn't include very much practical knowledge, so
Yeah, not yet.
it's just like a chapter that like you can just debate on how AI will progress over the next couple of years. But I think that you have missed like covering the part of AGI or ASI.
Oh, okay. Yeah, that's the thing I missed
It's like
because
this was
you can go ahead. Go ahead,
the,
Omri.
the
Tell me about it.
the final two parts of the chapter, where like basically AI that have been created till now is like models that are specified for doing a certain tasks and mastering doing certain tasks. And those tasks like could be whether like generating an image, recognizing speech, or like even playing chess.
Mm-hmm.
But the AGI that like people have been trying to accomplish is like a single model that can basically do anything a human can do.
Mm-hmm.
Basically, just like a general model.
Mm-hmm. Mm-hmm.
And that is the point that they were expecting in AGI in a couple of years. Like the scientists have been like very, very optimistic about like the progression of AI through the years, where like some sort of they said that like in 6 years AI can like beat or like can be able to play chess. And like it didn't happen until like 4 years after that.
Mm-hmm. Mm-hmm.
And like in the same sort of like scientists are like predicting the AGI or uh, yeah, predicting the AGI to like to happen like in some sort of near future, and like we don't know like when exactly.
Mm-hmm.
But like basically, like the AGI is like an AI that can do like basically any human task that a human can do. And like, until now, AI cannot do or like cannot solve a problem a human can't already solve. That's the point.
Yeah, yeah,
Like
yeah.
yeah, AI can definitely like do things better than human, like controlling machines or like doing like systematic stuff or like stuff that requires like extensive work that a human can't like keep on with it. But like basically any problem that AI can solve right now is like a problem that a human being have solved before. And like to the next point where like we progress from AGI to ASI or the artificial super intelligence. At this point, like the AI would be capable of solving even problems that are more complex for a human mind to conceive or to be able to solve. And like at that era, we would like witness a breakthrough in this technology. And like some say that the AI is the natural evolution of a human being, and like the next era would be like just robots like, controlling the universe and stuff like that. But like until that point, like where AI is capable of like solving a problem, like you can ask him a problem that humanity haven't like solved yet. At this point, like we haven't reached the AGI yet.
Mm-hmm. Yeah, 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 yeah.
So yes, that was pretty much it.
Mm-hmm. I think like in a few decades ago, like AI were just too far fetched from human that we don't really think about that problem. But nowadays, as we feel like we are coming close, that the idea
Mhm.
trying to think of AGI had been somewhat in the horizon.
Some sort of yes.
Yeah, kind of. Although we don't really know how would. Also, AGI is kind of like another concept that's kind of plaguing from time to time. Like it's not exactly easy to benchmark. Like so far there isn't a single benchmark that can tell us whether we've achieved AGI or not. And sometimes our acceptance of like human intelligence have been moving from time to time. So, but I think people are just trying to be optimistic, or they trying to say that we might still need to pursue like a holistic goal, rather than just like pushing to the edges in different directions. Anyway,
Mhm.
I think then that's kind of the thing about this chapter. I think maybe people can share a few words about how you feel about reading the chapters before we move on to talk about do you want to continue this book or what chapter do you want to read. I'll just like pick a few people that to share their thoughts. We have Battles here. Battles, are you there? Hi, Battles.
Yeah.
Yeah, how do you feel about the chapter or the book?
Oh, I mean, it was some parts were interesting, but overall it was like just history. It doesn't interest me that much, you know.
I think that's a feeling that pretty much everyone had in the first chapter.
Yeah, yeah. Some parts were interesting. I also liked the part uh, where he like described. Uh, what can be done in the future and how people are focusing on expert systems, but in the long run, it can be not beneficial to the AI as a whole.
Yeah, 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 yeah.
I found that interesting, and you covered the chapter really well.
Got it, got it, got it. I'm just curious, how much time do you spend on reading a book?
What?
How much time do you spend on reading a book? I'm just trying to
Oh,
get a yeah, survey.
like 3 hours,
3 hours, okay.
but I mm, didn't focus on every line.
Yeah, yeah,
Yeah,
yeah,
but
yeah. But is that sufficient for you to understand what we're talking about? Is that
yeah,
enough?
yeah.
Okay, then that'll work. That'll work. Yeah. Okay. Me also pick other person. I'll just have everyone share about their opinions because I think this book is I think it's currently between like whether you want to finish it or not. Like it's a bit undecided. Uh, um, Victor, are you there?
Yeah.
Yeah. May you share your thoughts about the book after I know you hadn't read a chapter, but how do you feel about listening to this?
I mean, it was. I mean, it's mostly history at the start, so like, I think it will definitely get more interesting later
Mm-hmm.
on. It's it feels like the book is gonna be interesting overall. I feel.
Oh, okay. Are you still gonna read the book?
What?
Uh, are you still interested in listening or reading through a book?
I mean, yeah.
Oh, really? Wow. Okay. Okay. Got it. Got it. Okay. And sure. Then let's ask Sherman as well. Hi, Sherman.
Yo,
You
okay.
good?
Yeah, I've been okay. There's just so much information, but for the book, it's just a bit tedious to go through. Like, especially for me, like I've not touched a book in like so long, so I
Mm-hmm.
spent like about 3 hours trying to digest like 10 pages. So it gets a bit difficult to commit. Plus,
Got,
there's like so much history.
got it. Got it. Got it. Got it. Got
So
it.
there's gonna be
I
like a
like
bit of friction.
the issue with like history is like you don't know like exactly which information that you should memorize and like which information that you should like just like run through it. Like you're always paranoid like if you just run through this exact say like this exact information it will like pop up in the exam or something like that. But this is my issue. Like it's like history is all about memorizing and stuff like that. So that's why I don't like it. But yeah,
Yeah.
here we are.
Also, in order to read this effectively, you need like a very strong heuristics to just filter out information that is probably not important. Then also would write everything as if it's important, but as a reader, you need to say, okay, this entire chapter or this entire page isn't actually that important to you, so I'll just skip it.
It's like the thing I'm bad at is like, for instance, memorizing names.
Oh, you
Like,
really
I'm
need
sure
to do
like
it.
probably names would be
Yeah,
it would be like
all the times, right?
some sort of important information.
Or
Like definitely times, but like the teacher said that she's not gonna include times in the example.
yeah, she's not gonna.
But like I don't know about she didn't say anything about the names. Like I'm also bad at like memorizing names of people that like did specific inventions.
Sure.
But like
Sure.
I could get like I grasped our like the inventions and the progressions that they have made, but like exact name of a person who did that would be quite hard.
Sure. Sure. Sure.
But like anyway.
Sure. Okay. Let me think about it. I think because like, I that also has been 2 weeks past since we for a semester or something. Um, we definitely have like lots of different subjects to read. I think maybe we can try to discuss a bit about like, is there other books that you are interested in reading, or are we still keen on reading this book by itself? Because for myself, because I'm very certain that I'm gonna be an AI engineer in the future. So for my part, I think this book is definitely I need to read at least half of it, but it's just a matter of like when I want to read it. Is this the best time to read it, or can I read it like half a year after or something? Yeah. I'm just also ask you a few questions. Like, what subject currently struggle you the most? We can have wholesome answer first.
What subject? What?
Yeah, yeah. Are you in Germany yet? Just to sure.
No, like I'm still like
Okay, okay.
still there's some
Then
issues.
among all the courses we and you had, like what subject are you struggling the most?
What subject do I struggle the most with?
Yeah.
Uh, I'm probably like I don't think that the first semester has like hard subjects.
Okay, that's good.
For
That's good.
instance, like that one, like the AI, like I would say that it is the most extensive, or like the most crucial subject of all.
Oh, okay. So you do think that intro to AI is like kind of crucial to you because
Mm-hmm.
yeah.
Yes.
Okay. Got it. Okay, we'll just ask you one by one because this is I want to know all your ideas. Anyway, ask Victor. Victor. Hi.
Yeah, hello.
Yeah. Which subject do you hate the most or struggle the most?
Sorry?
I mean, which subject do you struggle the most? Yeah.
Ah, I mean, I'm mostly annoyed with computer science because she's asking for a lot of specifics and formats and shit. Like material to do it is easy, but you have to spend a lot of time to just format the homework the way she wants it. You know?
Okay. You mean foundational CS, which we hand compute the some 128-bit number or something.
Yeah.
Okay. 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 I may also add bottles.
Yeah,
What is the subject you find the hardest?
I don't know. I don't think we have hard subjects. Like on every subject,
Wow.
for now we have similar things. But for me, it would be math. Like the teacher is like scaring us. He's saying that only 4 out of 100 people have passed.
Yeah.
And I don't know what to expect, like how much he wants from us. If it's on the level of the exercises,
Mm-hmm.
then it will be okay. But yeah, I don't believe that so many people haven't passed if it was level of the exercises.
Sure. Okay. Yeah. Okay. How about Sherman?
Okay, for me,
Boy.
honestly, this subject, Intro to AI and OS, because they have like so much theory, which I honestly struggle with the most.
Oh.
So there's that.
Hmm. Got it. Serious OS. And math is not a big problem to you yet. It's
Yeah, not yet, not yet.
not yet. Okay. Sure. Okay, at least I got your ideas. I think I was thinking about it, but I think generally it seems like at least to half of us, or I think a majority of us, this book is still somewhat useful, and it's a matter of time. How do we continue with the book, and what chapters do we pick? I think from now on, I don't think we probably don't need to read every chapter from 1 to 17 because there's like first order logic. Like we already learned about those. Like we spent so many time studying those things. So this and this is probably gonna be skipped or something. So um, for now on, I think we are gonna do this meeting like either once every week or once 2 weeks. I'll announce the channel. I'll announce in the chat and see who's available for the next host. But overall, I feel like this book is still somewhat useful to a majority of us. So I'll still keep this study group to be functional. Hey, you want to say something?
I want to ask you, like, what about you? Like, what is the most intimidating subject for you?
Oh, to me, what's the hardest or interesting subject to me? Is it? Yeah, I think to me it's probably mathematics and this one. I think mathematics is a bit harder because I just spend a bit more time studying analysis, if you know what that means. Like
Mm-hmm.
I'm kind of interested in analysis plus a few like set theory theoretical stuff. So I think I feel like I probably study like more than 10 hours for
You mean like
mathematics.
data analytics?
No,
Data
analysis,
analysis?
mathematical analysis.
Okay.
Yeah. So I think I probably spend like 10 hours reading mathematics every week at least, not including the time spent in solving problems. But that's for kind of like the math solving part. But in terms of like the subject I find most interesting, I think it's probably this book as well. Because in order to be AI engineer, there's actually lots of like I think mindsets and philosophy and methodologies to design your system to be learned quite a lot. I mean, just knowing how machine learning works or doesn't really make you be capable of like doing actual AI work as well. There's like lots of pitfalls you will see here and there, and lots of challenges to resolve. And if you are not really equipped with like the correct mindset or to make yourself somewhat resilient to problems that you haven't really touched before, then you should probably try to do it either by reading a book, either by utilizing knowledge in the later stages as well. So I think I'm still gonna read this book. I actually have a few AI engineers, like two or three friends that work as AI engineers. They also think that this book is a must read. You probably don't need to read the entire book, but you kind of have to know every concept or strategy that it kind of tells you. Yeah. So that's my idea. Yeah. So I don't think there's a, like. I think as far as what I collected, there doesn't seem to be a single book that people are more interested in than this one. Although there's not much of us that's left, but I think I'll still try to have this book be
I
covered.
think there is one that I have been reading
Which one?
along with this one.
Which one?
The one for computer science.
Oh, you mean I have lots of books. You mean Intro to Theory?
Not computer science. Okay, the operating system. Sorry.
Oh, operating system. Let me check.
I'm just trying to find it.
You mean Modern OS or something? Modern Operating System? Is this one?
Modern Operating Systems, yes, by Andrew S. Tannenbaum.
Yeah, okay. I don't remember an Andrew officer.
That one.
Probably this one. Yeah, probably this one. Yeah, this one is also quite hard. I mean, the first few chapters is a bit brutal.
I've actually read the first chapter, like the introductory to this book, it have like give me a very very useful knowledge into operating systems and things that it was like pretty much the first time I've heard about.
Yeah, it's kind of. I think there's also a chance that we can read this book instead. Depends on like how well we want to be, like what's the focus of each of us. Like I'm also personally reading this book, but the book is a bit intense as well. Like, yeah.
It's quite aggressive, yeah.
Yeah, but I think this book, if you were to somewhat talk about it, it might be more useful to our exams, because I kind of heard that the Intro to AI exam is actually pretty easy, but the OS exam is actually a bit harder. So if you want to make our grades better, there is a chance that we can read this book instead. Yeah.
I'd say like if you would be down, like if any of you guys would be interested, we can like schedule another session in parallel with this one.
Yeah.
Throughout the week, that we can read both. Like for one, we would read the one about operating system.
Really?
And the other
Yeah. I mean, we also can.
Because pretty much it would be like a summarizing session or like a discussion session. We would discuss what we have read.
Sure. Yeah.
Yeah, like it can be like that. Everyone reads the exact chapter and then open and discuss the content of this chapter together.
I mean, I think we can ask. I think let this be the last discussion we had, to ask whether people are interested in OS book. Are they more interested about it? And then I'll think about it, because I probably cannot make a decision right now. Let me ask Sherman. Hey,
Yes.
are you feeling better about the OS textbook or the OS subject overall?
Okay, not yet. I think I would wanna like spend time on the AI book first.
Yeah.
If not, it'll be like a bit of an overload for me.
Yeah. I'm just asking. Sure.
So yeah.
Sure. How about Victor and Battles?
I mean, I think the subject will be kind of hard for me, also because like I haven't studied operating systems as much, so maybe I would spend some time on that book as well.
Okay. How about Battles? Are you good about operating systems?
Yeah, and now I'm doing the math book. I am like, I don't know about operating systems for now. Yeah, I think I'm just doing the math book now.
Yeah, okay, sure. It's fine. Okay.
No one's interested in operating systems.
Yeah. I mean, but I think the book is hard. Yeah, the book, the book. There are books that's kind of demanding. I also find myself, because I study math so much. Although I know that there are all concepts out in OS I don't really know, but I don't have enough time to study it at this point.
Mm-hmm.
Yeah, it's kind of sad. Yeah, I hope I still pass the exam.
No, I think it would be okay. Like I also think that like the professor that is teaching OS is like pretty much is working aligned with that book. Like
Yeah.
he's basically
That's true.
like if you're done, like I can do the summary myself. Like we can.
Yeah. I think probably not now. I think. Let me think about it. I think the major trajectory we can do now is probably still doing just a AI book and mathematics, if people want that, and then the OS book, because there's like a small time of vacation before the final exam, right? So I think I'm probably gonna still read this book occasionally, probably 2 to 3 chapters throughout the weeks, and then we can think about whether we want to do you can even call it like a cramming session before the OS exam or something. So that it's more effective, but we also weren't obligated to read the entire book like week by week. Yeah. Yeah. But I think we do
I think
kind
that
of
would do.
always is something that people are concerned about as well. It's just that it's a bit hard to progress on. Okay, sure. Thanks for all of your participants. I think still most people are kind of interested. I'll just message whoever is available in the following weeks. Next session is probably gonna be in 1 to 2 weeks or something. But I'll do my best to at least announce that what we are gonna read in like 1 to 2 days. Yeah, and you can just allocate your time to see whether you are available to read it, or you can just listen aside. But I'll make sure
So
that.
like
Mhm.
the next week we're gonna discuss the second chapter in this.
I'm not really
AI.
sure. I think Bartos is a bit busy, so maybe 2 weeks after. But I will still confirm this fact with him or the other girl. Yeah, to see which chapter want to read, the following, and then when do they want to do the guidance. All right.
Okay.
Okay. That's it. Thanks for the possibility. See you tomorrow next time. Bye.
Keep me updated then.
Yeah, of course.
Thank you so much.
Bye.
Okay, sure. Bye.